Alright, so today we're going to expand on what we talked about yesterday. Tomorrow we're going to let you choose your own method, so your three choices are going to be substitution, elimination, or graphing. And then next week, Monday, we'll start reviewing for not only your test, which is next week, Wednesday, but we'll also start reviewing for the final, which will be I think it's Tuesday after, actually, here I can look. I think it's the Tuesday after Memorial Day. It's either Tuesday or Wednesday. It is Wednesday, day 2 of final. So it's the Wednesday after Memorial Day is your final. Okay? So at this time, we're in the L6 notes. Please do the 2 warm-ups. I think there's only 2 warm-ups. Please do the 2 warm-up problems there. All right, so if we're going to solve by graphing, we should probably have something straight because we got to make our straight lines. Okay. First one, top one, we'll call it blue. Do I like the form that it is in? This one right here. Do I like that form? Yeah? Okay with it? I don't want to rearrange it at all to make it look even better, or are we okay with it as it is? What are you thinking, Lisa? So I'm talking about blue. That's why I put a box around it. Keep it the same? Okay? I'm going to change it. I'm going to make it look like y equals negative x plus 3, because then it's in y equals mx plus b form. Okay? So Bryce, what's my y-intercept? Okay, so where's that? From the origin? Yep, up 3 from the origin. Okay. Tom, what's the slope of the blue line? See, this is why, by the way, we put it y equals mx plus b, so we know what the slope is. It would be what over what? 1 over 1? We're going to ignore that then? So it'd be so what's the slope? Negative 1 over 1? Okay, so I need 2 directions and 2 numbers. Down one and right one? One and right. What if I didn't want to go down and right? Up and left, right? Up 1, left 1. Okay. Then that color we want solid. And then draw it in. We go all the way across our graph, right? Arrowheads outside the graph. Okay. All right. So we gotta go to the next one. Do we like the the green one as it's written? Why not? I gave you a hint in the blue one. That's why we want to write it that way. What do we want it to look like? It's a form. We want it to look like y equals mx plus b, because then we can find our b and we can find our slope and we can graph our line dimensions. Right? Okay. So if I want to get this one into y equals mx plus b, it means I want it to look like this. I want it to look like y equals, right? What would I have to do? What would I do with 3x? How? No, we can't just willy-nilly just up and move it. We got to do some math to it, right? So how am I going to move it? Anita, she's struggling. How am I going to move that 3x? I'm going to subtract it from both sides. Okay? We got to add, subtract, multiply, divide. It's the only way we can move stuff. So we're going to. Oh no! That's the wanted to get in, so that was so that we get rid of everything but y in that thing. What? Oh, sorry, Michael. That's why I'm like, I know you knew what to do. Like that's why I was kind of struggling. Why are you struggling with this? Well, you can if you want. Yeah. Negative 3x. Then. Negative 3x plus 1. Because we can't combine those because 1 doesn't have x. Okay. Okay. Right? Offset. Talk to me about negative 3x plus 1 and its graph. One conversion, that's my y-intercept. That's the one part. Okay. Then what? Down 3 and right 3. Do we all agree with down 3 and right 3? There's 0 people that are agreeing. You want to give it one more try? Down 3 and what? No, the right part was good. We got to say down 3 and right 1 because it's negative 3 over 1. But that's not even what you said because I know you said down 3, right 3. Well, but that's, you know what I mean? I can only go with what you said. I can't read your mind. Okay. And then we draw in that line. Okay. Yeah. Did those two lines intersect? Yes, they intersected. So that means we have an intersection point. That means we have a solution to this system. What is the solution to this system of equations? Five comma 1 would be 1, 2, 3, 4, 5, comma 1 would be way over there. 1 comma 5 would be 1, 2, 3, 4, 5 up there. Which way do we go to get to get negative 1? Okay, that gets me over there, and then how many up? 2, 3, 4. There we go. Okay. Mr. Gomez, what should we do now? And don't say go to number 2. We should check our answer, right? Do you remember how we check our answer? Well, how are tell me what I put in for what? Twice.
For the blue box in 4 equals 3. One.
3.
Minus
Okay.
negative 1.
What is 3 minus negative 1? First off, do we like minus and negative? No, what do we do with those? Okay, what's negative times negative? So I can make those positive. All right, what's 3 plus 1? Is 4 equal to 4? Okay, that's one of them, right? Halfway there. What's the next one?
4.
No. Do I have to go back to my original equation? Okay. You can look at your paper too.
parentheses, -1 plus 4.
Negative, or 3 times -1. -3 plus 4 is 1 equal to 1. Now we checked it. Now we have the right to circle. Okay. Ms. Keaton, now we can move on to number 2. Solve by substitution. Do you remember what step number 1 in our substitution steps was? Or what? Solve one of the equations for one of the variables, right? Do we have that done for us already? Yeah, we do, because we've got a y equals equation as our first one. Yep, so that's done for us already. Now, if you didn't notice, these are the exact same problems. Okay? So we should get -1, 4 for an answer again. We just got to show it that way. Okay? And by the way, what's step number 2 from substitution? So I'm going to put this green box in place of y in the other equation, right? Okay? Okay? So then that's going to become 3x plus 3 minus x equals 1. Do you agree with that? Okay, I would too. Ash, what's step number 3 from our substitution steps? L3 or L4? Heck, I'd even go L5 because step number 3, 4, and 5 are the same in both substitution and elimination. We're going to solve that equation, right? How am I going to solve that equation? And what do I get? 2 x's. And then I still have that plus 3, and that still is equal to 1, right? Okay, now what? I'm going to get x by itself. Minus 3 from both sides. Love it. Do you know what 1 minus 3 is? -2, did you say? Yep, good job. And one last step. Divide by -2, or excuse me, divide by 2, yep. And -2 divided by +2 is -1, right? That's good. We got -1 over there for our x value. Love it. Okay? And we're coming all the way back over to you. What's step number 4 in substitution now? It's also step number 4 in elimination. Either of the original equations. You want to go top or you want to go bottom? Because it's already y equals, right? Yeah. So let's make it easy on ourselves. Less, less to do. Let's face facts. Let's be easy on ourselves. 3 minus. Now this is -1. Okay. What is 3 minus a -1? Nope. Nope.
2.
Nope. Do we like minus a negative? No. Who said it before? Who did the minus negative? Was it you, Kim? No. What? Was it Adrian? Did you do minus a negative? Yeah, you did. You did minus a negative. Adrian did minus a negative for us before. Remember what he did with it? Made it both plus, right? Yeah. Okay. Okay. So then what's 3 plus 1?
4.
4. Okay. And then I'm going to write my answer in my point form. We already checked it because it's the same problem, so we don't have to check it again. If it were a different problem, we'd have to check it. We just got done checking it's in red. Yeah? No, right. So yesterday we talked about solving by elimination. Okay? And when we solve by elimination, first we've got to get opposite coefficients. Now yesterday in my classes we talked about what it meant to be opposite coefficients. Ray, I'm not going to ask you because I didn't have you yesterday in class. So I'm just going to tell you if that's okay. You okay with that? Okay. The opposite coefficients. So first off, coefficients, if you don't remember, coefficients are the number in front of a variable. Okay? That's what a coefficient is. So we're looking at those numbers in front of x and the numbers in front of the y's. Okay? And we said yesterday, that we need one of them, we need them to be the same number or the same digit, only one of them has to be, actually I don't want to use the number one because you get confused and you think you're going to get the actual one. One's got to be positive and one's got to be negative. So it's the same digit, one positive, one negative. Okay? Looking here at number one, at example number one, do we have that set up for us? Ray, I'll ask you that question. Do we have the same digit in front of our x's or in front of our y's? No, we don't. So then we're going to have to multiply one or both of those equations by a number. But before we can do that, I'm going to give you one follow-up question. It's an easy one. I know that you're going to nail it right off the start. Before we do that, we have got to figure out what variable we want to eliminate. So what do you want to eliminate, x or y?
Y.
Y? Okay. So we're going to choose y to eliminate. Okay? So that means that I need to get the same number in front of y. So if I'm looking at -4 and -2, what is a number, Jason, that both -4 and -2 go into? -4, right? Yeah. -4 is a number that they both go into. So I don't have to change this top equation at all. That's going to stay 3x minus 4y equals 14. Okay? Mr. Guy, I need one of them to be positive and one of them to be negative, right? Currently, they're both negative. So the number that I'm going to multiply has to be negative because I need to get a positive out of it, right? Okay? So 2 times what gets me 4? So we're going to multiply both sides of that second equation by -2. Yep, exactly. We're going to multiply this entire equation right here by -2. And then we're going to draw our arrows in because we don't want to miss it going into one of our spots. Okay? Izzy, -2 times +5. -10. So that's going to be -10x. -2 times -2, Izzy. +4. So then this becomes +4y. And I'll give you this one because it's a bigger number. -2 times -14 is +28. Okay. Chloe, do I now have step number 1 set up? Do I have the same digit in front of the y's, because we chose y's? Do I have the same digit in front of the y's? Yep, they're both 4s, right? and is one of them positive and one of them negative? Yep. Okay. So I'm done with step number 1. Okay. Then we said yesterday, step number 2 is we have to add those two equations together. Okay. So if in my classes, I said we put a big old plus sign there, and we put a big old line underneath there. Okay. Positive 3x plus negative 10x. Or 3 minus 10. Negative 7, right? Yep, negative 7x here. Negative 4 plus 4. 0, that goes away. That's the elimination that we needed to eliminate. We eliminated the y. Now these are big ones. 14 plus 28. 42. Step number 3 says now we've got to solve this equation. Right? Okay? How am I going to solve that equation? By negative 7. Yep. We got to divide both sides by negative 7. Do you know offhand what positive 42 divided by negative 7 is? Negative 6. Exactly, it is negative 6. Now we're through step number 3. Step number 4 says it's the same as what we did in substitution, where now we're going to substitute this negative 6 value back into either one of our equations. Which equation would you like to choose? Top equation? Okay. So I'm going to say then here that we've got 3x minus 4y equals 14. So that's going to be 3 times 3 times negative 6 minus 4y equals 14. Right? 3 times negative 6. Negative what? 3 times negative 6? Negative 18. Right, so I want to solve this for y. What do I want to do first? Why would I want to move the y if I want to solve y? Let's just leave it there. Let's not make extra work. So if I want to leave the y there, means I got to move the 18. I'm going to move the 18. Is it already being corrected? Isn't it already being corrected? So how am I going to move it? Add 18. Yep, I got to add 18. Because if I subtract it, then I'm going to get even more on that side. Okay? So I got to do the opposite. So I got to add 18 to both sides. That's going to give me negative 4y equals, 32, I think. 4 plus 8 is 12, right? So that's 2, carry the 1. 1 plus 1 is 2, plus the extra 1 is 3. Yep, that's 32. 32 there. Lisa, how am I going to finish this one off? I'm going to divide both sides by negative 4. Do you know what positive 32 divided by negative 4 is? Negative 8. Okay. Adrian, we're up to you now. How am I going to write my answer? It's literally written for you right here in step number 5. How am I going to write the answer? Negative 6 comma negative 8, because it ordered pairs are x comma y. Yep, exactly. Negative 6 comma 8. And then what do I have to do before I've earned the right to circle it? We got to check it, right? Yeah, okay. So 3 times negative 6 is negative 18. Minus 4 times negative 8, that's going to be positive 32. Negative 18 plus 32 is 14, and 14 is equal to 14. Checks out in the first one. 5 times negative 6 is negative 30, minus 2 times negative 8 is positive 16, and negative 30 plus 16 is negative 14, which is negative 14. Checks out both. Now we've earned the right to circle it. Yeah. You will have the benefit of using a calculator when you do those at home. I would like to skip to number 4 because I would like to do a word problem and then we can solve the word problem using elimination. Okay? A farmer saw some chickens and pigs in a field. He counted a total of 60 heads and 176 legs. Write a system of equations. That means we need to write 2 equations. To solve to find the number of chickens and pigs in the field. You might argue, if the farmer had time to count heads and legs, why didn't he just count the number of pigs and chickens? Well, that may be very true. What kind of a cool math problem would that be? Kiana, we're up to you. We have to define 2 variables. Okay? What was the first variable that you would like to define? I need one of the 26 letters. H for. Ooh, but what are we truly looking for? Because I know the number of heads in the field, so we don't need to find that. Chickens and pigs. So do you want to stick with H, or do you want to change it to a different letter? C. Okay. And what is C going to be? Number of chickens? Yeah. I'm going to give you a 2 for 1. You can pick the next letter too. 4. Pigs. Yep, exactly. That's it. You and I were thinking exactly alike. C for chicken, P for pigs. Love it. Okay? All right. Promise. Okay? Austin, out of that first, I'm sorry, not out of the first sentence. Out of the second sentence, can you come up with an equation for me? Actually, before you do that, let's talk a little bit about biology. Okay? Have you ever seen a chicken? Okay? Have you ever seen a pig? Okay, then that makes you an expert for these next 2 questions. Actually, sorry, next 4 questions. Okay? On a chicken, how many heads does it have? 1. Okay? That's good to know. It has one head. How many legs does a chicken have? 2. Okay? Also very important. Some people don't know. Some people are city folk. Okay? Right? Pigs. How many heads does a pig have? 1. And how many legs? 4. Now, once I stopped at one of these like roadside like weird attraction things in Kansas, and I saw a pig with 5 legs. It was the grossest thing I've ever seen because it had an extra leg coming out of its neck. Still gives me nightmares. Okay? All right. So now, based off of that, actually, Austin, you did enough answering. You answered a lot of good questions. Anita, give me an equation based off of heads. Total heads. There's what? Okay, so I need the equation off of that. Well, how many chickens do we have? Yeah, we do. How many chickens do we have? C. We got C chickens, right? Okay. How many heads does each chicken have? 1. So that would be just C. Okay. Pigs. How many heads does a pig have? 1. So that would be P. And how many total heads are there? There's 1 equation. Okay. Okay. You get the equation for legs. Yep. Okay. How many legs does a chicken have? You know, how many legs does 1 chicken have? 2. So that would be 2 C, right? 2C, because C is chicken, right? Okay. How many legs does a pig have? So that would be, and how many total legs are in the field? 176. There, I've set it up for you. Actually, you guys set it up for yourselves. You guys now solve this system of equations using elimination. Solve using elimination. Okay? Right here are your 2 equations. You need to solve for P, you need to solve for C, and you can't just give me numbers here because numbers don't tell me what it is. You have to tell me in words what it is. Go for it. Ash, what's you? C or P? What do we want to eliminate? C, get rid of C. Okay? So if we're going to eliminate C, that means, Ms. Lightweight, I need to have the same number in front of the C's, right? Which means I'm going to multiply the top equation by 2, but I also want 1 to be positive and 1 to be negative, so instead of multiplying by 2, we're going to multiply by negative 2. Correct. We're going to multiply this equation by negative 2. So I'm going to multiply there, there, and there. That gives me negative 2C minus 2P equals negative 120. Okay? Then we can leave this other one just the same. 2C plus 4P equals 176. Step number 1 now is done, right, Ms. Lightweight? Step 1 done? Because we got a positive 2 and a negative 2 in front of our C's. Love it. Step number 2, Ms. Keaton. What I heard you say was add the equations together? Yep, because then that's going to do what you said. That's, if I add the equations together, that's going to eliminate the C's. Negative 2 plus 4 is 2. This is 56. Step number 3, Jason. We're going to solve it by dividing both sides by 2. So P is 56 divided by 2, anybody? 28. 28. So that means that there are 28 pigs that we think of so far. Okay? Then, if there are 28 pigs, I'm going to go C plus P equals 60 here in step number 4, which means that C plus 28 is 60, and I can subtract 28 from both sides. That gives me C is 32. Quick check. 32 plus 28 is 60, so I have 60 heads in the field. That's good. A chicken has 2 legs. That means 2 times 32 is 64. A pig has 4 legs. 4 times 28 is 112. 64 plus 112 is 176. We have 176 legs in the field, just as the problem told us. So our answer here is not going to be a ordered pair. Our answer here is going to be there are 32 chickens and 28 pigs in the field. Okay? That is our answer. Have yourselves a great, grand, and wonderful day.